So this is the first of a whole bunch of content that we've got coming regarding Akka to ZIO. And I guess depending on where you are in the Scala world or where your organization is, this may be either a big deal for you or not a deal at all. If your company is just doing stuff with ZIO and maybe you're worried about upgrading to ZIO 2, then this really isn't going to affect you other than maybe you're going to get some nice things that get developed over the next couple of months that you'll get to take advantage of too. But this is kind of all a bunch of noise for you. But I think there are a bunch of other people who have been using Akka in their organizations because Akka has been around for a really long time. When I first started learning Scala, actors were actually in Scala and then they got like moved out into Akka. But Akka has been around for a long time. And so a lot of organizations have built stuff on top of it. And because of a recent change in their licensing policy, a year from now, if you don't do anything, you're potentially going to be on the hook for millions of dollars for doing exactly the same thing that you were doing this year, which you can imagine probably with any economy kind of going to your manager or even in your family, you imagine the other and being like, excuse me, this thing that used to be free, we're now going to need to pay millions of dollars for it. So can I get some extra budget for that, even though it's exactly the same? Is not necessarily a conversation that everyone wants to have. And so I think a lot of people are taking that and using it as an opportunity or maybe a forced opportunity to think about where they want to go. And I think one alternative is, do they want to be in Scala at all? Or do they want to just rewrite this service in Go or in whatever language you pick? Or do you want to stay in Scala? And if so, what are the options in Scala? And obviously one of the options that maybe Kid and I are biased, but we are big fans of is ZIO. And ZIO is 100% free, 100% open source, will always be. We're actually in the process of putting steps in place from a legal perspective to ensure that that's the case, and that if you are an organization that's using ZIO, you don't get the rug pulled out from under you the same way that people who are using Akka have now.
Yeah, we're gonna make an NFT that ensures that. I'm just kidding. I don't know what they're doing, but that's cool. That sounds like a nice thing to have.
But in addition to all that, just there's work to be done. Even if ZIO is great, there's work to be done in going from Akka to ZIO, just because even if everything you can do with Akka you can do with ZIO, you probably do it in a slightly different way. And so this is the beginning of a set of content that we're developing to make it easier for people to do that if they do need to or want to do that. And so today, I think this is going to be a little bit, other than my maybe overly long introduction, is going to be a little more of just a traditional symposium where we're going to talk through some of these concepts. We're going to work through some code examples and basically see how we can, if we had some Akka example that gave us some output, we can get very identical output by using ZIO. Then next week for Zymposium, we have this special panel discussion. We're going to have a ton of great folks. We're going to have Reverend John joining. We're going to have Michael Arnaldi joining. We're going to have a bunch of people who have actually done migrations from Akka to ZIO at their organization with large code bases. They're going to be able to talk about their experience, what worked, what didn't, things that got better, things that maybe were pain points. So I think that's going to be a really good resource for people. I think around that same time, we're also going to have a white paper coming out, which I think at this point is going to be like 60 pages or something, but is basically going to go through like every library you could possibly be using in Akka and what the ZIO equivalent is, and kind of talk you through like what that would look like with code examples. So I think that's going to be a really cool thing, and that'll be free as long as you give us your email address or whatever. So definitely, yeah, exactly. Definitely sign up for that. And then I think after that panel, we're probably going to start a series with Zymposium where Kid and I are going to be working through taking a medium-sized Akka application and just migrating it to ZIO, kind of the same work that we would do with an organization that we consulted with if that was the problem they were facing. And if anyone is interested in has a code base that they'd be willing to at least have some kind of edited video of someone working on, and they would like help with that, that could be something interesting. So please reach out to Kit or I if you would be interested in that. And then I think the other big development is, I think most people probably seen ZIO HCP has moved from Dream 11 to the ZIO organization. So Dream 11 did a fantastic job of developing this library, and it's really great. And now they're taking the next step of their contributing that to the ZIO organization so that we can get a broader set of people who are working on making that be as good as it can be. And there's been a ton of work on that over the last week. John's got involved, opened a ton of tickets. John and Kid and I have been working on a new API for defining APIs. There's been a ton of other stuff there. So I think that's getting really nice. And obviously that's a really important part of Akka HCP, is probably one important reason you may be using Akka, and having ZIO HCP be a really full-featured equivalent for that is really important. So I think that's most of my intro, at least as far as like where we are and where we're going. For today, I want to zoom in a little bit to some of the like core concepts of Akka, just like Akka, or just like ZIO. Akka is a whole ecosystem, right? So there's an Akka solution for configuration management. There's an Akka solution for HCP. There's Akka solutions for all these different things. And likewise, there's ZIO solutions. And when we do one of these symposiums, it wouldn't be realistic for me to say we're going to do a 1 hour symposium and we're going to like cover everything in the ZIO ecosystem. And likewise, I definitely don't want to like promise you that for this, we're going to cover everything in the Akka ecosystem. I think we'll build up to some of that over time. I think today I want to focus on actors, because they're in a way the like building block of everything in Akka. Just like in the ZIO world, ZIO and fibers are like the basis of everything. You can look at ZIO HCP, and it's obviously a library for defining servers and clients and working with them, but under the hood, everything is a ZIO and everything is a fiber. And likewise, when you work with Akka, well, maybe you're working with Akka HCP, but under the hood, everything is an actor. And I think a lot of times, just like when you're working with ZIO, you actually work with ZIO and you flat map your workflows and do these things. A lot of times with Akka, you actually work with actors. So I want to like talk about like what that is and like kind of how you would think about translating that to the ZIO world. And then depending on time, we'll explore that, and then we'll maybe get to some examples of Akka streams, and we'll see how those translate and how there are actually some really natural analogies there. And yes, we're definitely going to get to shard cake, because it's amazing timing that got like announced the same day that Akka or Lightbend changed their licensing policy. So that's, I think, a really like nice part of, I think, what the solution is going to look like for a distributed alternative to Akka. And I think that does also raise a good point that, like, overall, I think ZIO is fantastic. I think the underlying architecture of ZIO is like much more solid, and I think we'll see that as we go. But there's also a reality for all of us that we have to acknowledge that Akka has been around for a long, long time, a lot longer than the ZIO ecosystem has been around. And by virtue of that, Akka kind of has a off-the-shelf solution to just about anything you could come up with. Whereas there are going to be cases with ZIO where we're going to see, well, we can do a solution, but maybe we're going to have to put together a couple of parts. but maybe putting together those parts is worth saving a couple $1 million. Okay, anything else before we dive in here? All right. So what I've done here is I've just copied the hello world example from Akka's documentation. Maybe I'll just move this up here just so it's a little bit separate. So this is their hello world with actors, and I mean it's kind of interesting because it's it's pretty big for being a hello world, and we'll see that at least I find it has some complexity associated with it, but it's the hello world. So let's take a look at this and let's use this to kind of understand this like concept of what this actor is. And so the core abstraction in Akka is this thing called an actor. And if we wanted to describe it, we would say that it accepts messages. And at least in the latest version of Akka, there's a concept of kind of having a type here. So if we said like a actor of T accepts messages of type T, it processes those messages sequentially. And we can have some concept of other actors. And so like in Akka, this is called a actor ref, which is basically like a handle on an actor that you could like send it one of these messages. And that's basically it. And kind of the underlying idea here is that the actor encompasses mutable state. So all of these actors, we could have all these actors that are sending messages to each other, and all these messages are flying around, and maybe we're not sure what the order of these messages is going to be. But within each of these actors, within its own internal implementation, it's in a way a very orderly world of it's just going to take one message and it's going to say, okay, I got this message. I'm going to do something with it. I'm going to change my state. Okay, I got another message. I'm going to change my state again. And so within the actor, you don't need to use any, you don't need to use like atomic references. You don't need to use any type of concurrent safe data structures. Kind of promise of actors is that that is taken care of for you. And you don't need to worry about race conditions within the actor implementation because you're always just processing one message. And if there are more messages, just sit in the queue and they'll come off of the queue eventually. And I think the other thing that can be nice about this like actor analogy is I think it's a analogy that maybe scales up a little bit more directly to distributed systems, where if you think about, okay, on our little example, we're going to have 3 actors here. You could imagine, well, if I have like 100 different computers on my network, each of those computers could be an actor, and each message that they send is like sending a packet to each other. And so I think one of the things that was attractive about this was that analogy, which I think can be solved with other frameworks like ZIO, but there's not that like exact analogy of like this thing that you're working with on your local computer is exactly like this like node in a distributed network. Okay, so with that introduction then, let's look at this. And I'm using the Akka typed here. So there was another version before this where basically there wasn't this like input type of message. This is kind of the most recent one. So I thought it made sense to use that, but definitely if people feel like, oh no, you know, 90% of us don't use this, then next time we use examples, we can not use the typed examples. But for now, we'll go with this. And so what we've got here is we've got these 2 kind of messages, and this is like a pretty common pattern. We'll define each message as a case class here. And in this case, the message has some like string because we're just like greeting ourselves. And then it has this reference to this other actor that basically is the one that we need to, that like sent us the message. Because just in the abstract, if we just get this message, we don't know who sent it to us, which maybe is fine if the message is just like increment counter and we just, okay, we increment the counter. But if we need to like send something back to them, then we need the reference to send it back to them. So this is kind of defining our communications protocol here. And then this is defining our first actor. And it's doing it in terms of this behavior type. And that's kind of describing the behavior of the actor when it receives a message. So here, when we're saying when this actor receives a message and has access to some context, as well as the more important part for us here is this message. The first thing I'm going to do is I'm just going to print it out just so we can kind of debug it. I think in the original actor example, this was like a logging thing, but I didn't want to have to like set up logging just to like do our simple example. So I'm just going to print to the console. And then what it's going to do is it's just going to take that person that sent it the message, and it's just going to send them a message back. This bang thing is basically like send a message. It's kind of the Akka DSL for this. So send them a message back that like, all right, I have greeted you. Well met, sir. And then there's this little bit of a weird thing of we've got to return this behavior same, which is basically like, I feel like Akka is trying to have a functional API for something that's not actually purely functional. Like clearly this actor is stateful, right? When we send it messages, it may change the internal state of the actor. It may do different things in the future. This is kind of trying to hide that a little bit by saying, well, we're just going to like return this continuation that is like the next behavior we should run the next time we get a message. So it's kind of trying to, I guess, hide the mutability there, but it is fundamentally mutable. But okay, fine. So we got this thing. So basically, we send it a greeting, and it's going to print it out, and it's going to send back a greeted. And then we've got to have something to actually interact with this actor. So then we make this other actor. And this actor is going to accept, so this first one accepted greet messages. This next one is going to accept the greeted messages. So this says basically, well, if you acknowledge that you greeted me, then I'm going to increment my internal counter. I'm going to print this thing out. And then if I get to this maximum that I was constructed with, I'm going to stop. And otherwise, I'm just going to greet again. So basically, this guy is left. If we give this 3, he's going to like greet 3 times. And every time he's going to greet, he's going to wait for the other person to acknowledge his greet. And then he's going to do it again if he's not up to his maximum, or I guess her maximum. I should not be assigning genders to actor bots here. And then finally, we need this whole main thing to actually like start some of these and wire them together. So we need this actor system thing for this to all work, which you can think of a little bit as like the ZIO runtime of this kind of has the like underlying capabilities necessary to like track all these actors and manage the communications between them and so on and so forth. And this is going to have this method here, where this is yet another actor that basically, when we set this up, it's going to spawn one of these guys that just responds back to your messages. And then every time it gets one of these messages new, so we have a third thing in our protocol, the say hello message to start it, it's going to start one of those bots, which I guess right now is going to do 3 times, and is going to send the first message to kick the whole process off. So if we try running this, oops, what's going here? And this is hello world name. Okay. And so we see here we had this hello world. And so we get hello world, hello Akka, and if we count them, hello world, hello world, hello world. So basically we said hello 3 times, hello Akka, hello Akka, hello Akka. We said that 3 times. And then we greeted world 3 times and Akka 3 times. And I think if we run this a couple of times here, yeah, we'll see there's no, for world, these greetings occur linearly, which makes sense, but there's no guaranteed ordering between the Akkas and the world, that we have these like 2 different concurrent processes that are running at the same time. So this is kind of, I guess, this like hello world with Akka. I think one of the things that comes out of this a little bit is that in this world, like everything is essentially an actor, and that can be a little bit awkward where it's one of those, like if all you have is a hammer, then everything looks like a nail, but like the reality is the world is like more complex. So you could say, well, if we want to get this behavior, which I think could be like described as like we want to like call this thing with some input and get an output, and we want to like do it 3 times. We need to maintain some state, and we want these 2 processes to be concurrent. Is this the most natural way to think about it, or is it not? And I'll see. I was wondering if Kit had like already like subtly like done like a whole version of this with ZIO, but we will have to do it ourselves. But I think a lot of times it's not. So like in ZIO, there's a library called ZIO actors. And I would say it's not that active, because I think that's just not a problem that people like actually have very often in the real world. Like you might kind of think, well, I'm coming from Akka, I've got all these actors, I need new actors, so I need ZIO actors. And if you really want to, you can do that. But I think what most people who've migrated from Akka to ZIO have found is kind of the actor was one particular like way of solving a problem, but wasn't actually the solution to the problem. And there can be other ways of solving the problem. And so there are lots of ZIO libraries and a lot of activity of like ZIO HTTP, because okay, HTTP is a problem that a lot of people have, but I think using actors in ZIO is actually not a problem that most people have once they think about it here. So maybe, I don't know if, so Kit has some international man of mystery stuff going on today. So he is going to be a little bit of a ghost in the machine here. I don't know if he is still here to, I guess, be my foil. But maybe let me ask folks in the audience, I'll switch to Discord in a second, what tools or data types in ZIO do you think would be useful if we wanted to implement this with ZIO instead of with Akka? Okay, so we got some ideas about queues and refs, some stuff about STM. So let's kind of yeah, so I think there are like 2 ways that we might approach this. And so, well, no, that's not quite right, but so one would be to say basically, how do we replicate actors with ZIO machinery? And maybe a second one would be how do we re-architect this of ignoring actors altogether? So I think the first approach, I think someone had kind of exactly the right idea. And I think there were a couple people who were talking about cues of if we wanted to kind of live in this ZIO world, we could imagine like one implementation of an actor would basically be this. And maybe in the future we'll add more methods to it of we have a way to like kill the actor or send a poison pill or what have you. But a actor that accepts some type input, we have some ability to send to it. And if we really wanted to, we could do the little bang thing if we wanted. And that doesn't return any useful value. It just sends the message. It's kind of fire and forget. I think in some early versions of Akka, I think they had like the ask pattern where like it did return the value, but I think they didn't like that. But so it's something where we can just send it something and it's going to do something with it. We don't really know what. Maybe it's going to send us something back. And that's what it's going to do. And so if we had this, we could have something like, boy, Copilot is pretty good here. And I think this is probably right. So maybe we'll call this handle. So this will be like the behavior that the actor embodies. And if we wanted to, we could probably build environment and error types with all these things, but maybe I won't do that yet. And this is going to give me a UIO of actor. And then I think I'm actually going to do q.unbounded here. We could debate how we feel about that. But so I'm going to make a queue here. And maybe it's helpful I could call this something like the inbox of this actor here. Let's get some compilation going. And so then I could actually make this map. And I could say new actor. And so sending to the actor and actually is going to just be offering it to this thing. Maybe actually I'll make this UI of any here. And then what I'm missing here is I'm missing someone actually consuming the things from this queue. So I think maybe I will refactor this into a for comprehension here. And I'll say inbox in, well, it really wants to do the bounded one. And then let's say fiber. And so look how simple this is. So what this actor is going to do is it's going to take messages from the inbox. It's going to handle them. And then it's just going to do that forever. And it's going to do that in the background here. Maybe I'll make this fork daemon. And then I can just yield this new actor. And then yield. Okay. And that's all happy now. And so now if I wanted to, maybe we can make a quick example of our like actor here. So maybe I'll make like a final case class increment. Maybe I'll just make that case object in fact. And maybe I will want this to also be able to have some initial state here. Maybe I'll just myself an ability to myself. Let's create a graph. Call this image. Okay, so this ZIO here is going to allow me the ability to create some states. So I'll be able to like create a ref or something, or I don't think I'll don't necessarily actually need a ref because I'm going to process this sequentially. But then let's see if I can make an actor here. So I can say val counter actor. Oh, no, I don't need this. And this does, well, let's do this first, and then maybe we can show this here. Okay, so now my whole program, I could do something like for actor, and let's actually maybe to make this more clear, why don't I call this something like make counter actor? So I'll make a counter actor here, and then I can send it increments a couple times. And then this is example 1. Oh, and update it. Okay. And so you can see we've already got like a actor here that is satisfying his basic property we talked about. And this was actually pretty simple for us to do. If you really want this, there's that library ZIO actors you can use for it. So you don't have to do this yourself. But I think one of the things you can see here is how ZIO has a couple of these data types. So it's not just ZIO, but it's you have ref and you have queues and you have promises and you have fibers, and you get, instead of just everything being one thing, you get a bunch of these different things that you can put together so you've got the right tool for the right problem. Let's show maybe a couple of other things here just while we're here. So one thing we can do here is let me do ZIO dot select all list.fill 100 actor dot send increment. I'll make this collect all par. So we can see we got that same property we wanted of the queue is giving us sequentiality here. And in fact, we don't need the ref here. We could just define a var in here. So let me see if I can do that. So then I think I can just do Let me maybe come back to that just in the interest of time. Okay, so this is kind of one approach of the kind of still make things an actor, and you can definitely do that here. But I think this also shows a couple of useful things about like how to think about an actor in terms of ZIO data types here. Of the closest analogy to an actor is really a fiber here. That actors and fibers both represent running processes. And both of them can actually receive some types of messages. In the case of an actor, the type of messages that it receives is defined by its type signature here, right? That this actor receives greet messages. In the case of ZIO, fibers themselves accept a much more limited number of messages. So like you can interrupt a fiber or you can await its result. But what fibers allow you to do is they interact with the rest of your system by working with these other data structures. So working with refs, working with queues, working with promises. And that can give you a more flexible way of managing that communications protocol. But whenever you have an actor, you can think about, okay, there's really a fiber in there, and what input does it need to get or not need to get? And if it needs to get it, it can get it by taking things from a queue, by reading values from a ref, by waiting for a promise. But sometimes it may not need that at all. We may be able to do this in a much more simple way. So here was our little actor example, but let's maybe put that aside again, and let's come back to our original problem. So we wanted this greeter thing that basically every time we greeted it, it incremented this. Well, it actually didn't even increment. It just kind of just said like, hey, welcome. So why don't we try implementing this and try implementing a much more simple way. So like, what if we said, well, greeter, we give it a name, that's a string, and all it's going to do is it's going to give us back a string. And so this would be, and maybe the string it's going to give us back is just something like ZIO.succeed hello name. And maybe eventually we'll kind of come back and we'll, okay, I think that's actually the same thing. We'll see if we can line these messages up. So we give it a name, it's going to do that. And why don't we also, why don't we like debug this so that we, why don't we actually, maybe we'll do this. We'll say, and then we can just do reading. Okay. And so this will give us the ability to, I mean, let's just make this our, so if we do greeter, and I think the messages we were using before were, I guess, all right, so we'll do like hello world or hello Akka. We'll do hello ZIO. Do hello ZIO. So we'll do greeter and we'll say hello ZIO. And we got two hellos. Oh, so we should maybe just. Okay. And so I think here we're actually starting to see one of the nice features of not using actors for this stuff and just using functions or using ZIO workflows. So if we think this whole greeter thing, it was supposed to like we give it a greeting and it greets us back. And here we kind of have a lot of like, well, they send us a message and we send them back a message, which we'll see if we need to fire and forget semantics. We'll have a way to introduce those by forking fibers. But the simplest way to do this is like, okay, you want to greet me, I'll just greet you back. So then let's try to build more of this Akka example here. So then we kind of had this like bot thing is like the one that is like asking to be greeted. So why don't we try to do that? So let's say we have a bot and the bot has I'll just call it N. And this is how many times it should call a greeter. And maybe it'll take a reference to a greeter, which in this case, we could make this its own trait if we wanted to, and maybe we should. But we could also just view this as a function. So this greeter just this ZIO string. And this, I think, is maybe not going to return any value. And maybe what this is going to do is, let's look at what the previous one did here. So I think this one is going to say greeting, and then it's going to basically do this thing. Okay, so let's do, maybe I'll make it a lot. So let's say val once is going to be, and I guess this is going to need a name as well. So it's going to do this. And then it is going to call the greeter with the name. And then we could do ZIO replicate and greet once. Is that happy? That's not. I can just do ZIO dot. Oh, just do. These console operations can potentially fail if there's a IO exception there. So that's the only reason to get rid of those. Okay. So now I've got this bot that wraps all this up. Now, I think the only thing I'm missing here is I basically need to create a couple of these. And then, yeah, in this case, I could kind of have a version of this where this maintains some state, but that's not actually in the original example. So maybe we'll stick with this. So in this case, let's try something like or underscore in bot 3 ZIO greeter. And then we'll do another one. Okay, let's see what this looks like here. Okay, well, first I need to use some correct string interpolation here. This is more interesting. Okay, so we've recovered a decent amount of the power of the original example. What's still missing here? Let me go over the Discord for a second. So someone says back pressure. Someone says reply. So what I was actually thinking about here was concurrency. So in this original example, we fired off the world and the Akka, and let me see if I can run it again so we can see this. We see that we got these interleaved, right? That this kind of is fire and forget. And so we basically start this one going and we start this one going. And so we see these interleaved. Versus so far, we don't see that in our example. So let's look at that. Right. So in our example right now, we do world, 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 ZIO, ZIO, ZIO. So what's the solution to that? Well, we can fork these. And maybe now I'll call this 501. This is 502. And then maybe before I am done with my program, I'm just going to join these two. And so we see now we've got that interleaving. So one of the nice things about this model is we get a lot more of an explicit ability to control when we want those fire and forget semantics and when we don't. There were some cases here where it seems like maybe we didn't need the fire and forget semantics. Maybe when we greeted someone, we could just greet them and they could give us back the greeting. Versus there are other cases where we may really need to send this off and do something else while we're waiting for it. And one of the nice things about ZIO is just because we wait for a result semantically doesn't mean we're ever blocking. So let's say that for some reason we didn't want to do this, that we wanted this bot to complete all of its work before we started this bot. We're not blocking any threads waiting for that to happen. That's being done in a completely non-blocking way under the hood that's being driven by asynchronous callbacks. All right, so let's think about, so I think there's still a little bit of something that we're missing here. I think the Akka example kept track of these numbers. So let's see how we could do that. So I think then we're going to do, let's say, greeting N here. And maybe then I can just recurse here. And maybe I'll say if N is equal to, maybe I'll do a countdown. So if N's 1, then you're just done here. Otherwise, this will kind of count the opposite order, but it's probably fine for now. Let's see. Oops. All right, let's see. There we go. Okay, and we could kind of play with the order of this, of having another little accumulate here, so we count it up instead of counting down. But so this is now giving us essentially the same behavior as the Akka example, but we can see that this is dramatically shorter, and each of these is also now completely testable. One of the issues you can have with Akka, I find, is that like you've got all these actors and kind of there's no way to like test the actor without like spinning up the actor infrastructure and having an actor system and having other actors that are going to interact with it in like exactly the way you're expecting. Versus here, we can see that we can make these their own self-contained modules that are a lot easier to test. So I think big lesson from this on this actors is just the equivalent actor is really a fiber. And whereas actors kind of interact with the world in this one way of receiving messages, fibers interact with the world in whatever way they specify, which can mean taking items from a queue, which can mean waiting for a promise, which can mean checking a ref. And that gives you flexibility to define them and create them at the level that makes sense. So like here, we use this fork operator, and we didn't actually have to fork manually. We could rewrite this whole thing as if I just oh. Yeah. And so this now just says in an even higher level way of kick off these two processes at the same time. Let me check the Discord here. Oh, yeah. Yeah, so I mean, I think there were a couple of questions about like preserving ordering, and I think sometimes we need a queue for that. But I think one of the things that we can see here is sometimes just using actual like method calls and calling things and getting their results already gives us the right ordering. So like here, there's no explicit of, well, we're sending the message and then we're not doing anything until we get a message back. But when we call greeter is a function that takes an input and gives us an output. And so just by that definition of greeter, when we call this, we're not proceeding until this thing is done and has done its work and has produced its results, and we're ready to move on. So if you need more explicit messages, you can definitely do that. That's like this counter example we did above. But a lot of times, I think what people find is that they don't actually need that in a lot of cases, that you can just call things. Okay, let me, and one thing, by the way, I do want to highlight, we've got, I think, a really good audience here, and a lot of folks have, I think, done this in the past or have worked with Akka in the past. So not that we're necessarily going to get to everything today, but I'd really encourage you to both kind of share your impressions of things that both how you did that, as well as maybe things that are still missing, because I think there are some things that still maybe not even missing, but just not as nice as they could be. So like one of the panelists who's going to be here next week, Jan, he did this migration, and he did a talk about that was great at Functional Scala last year. And he, on one of his slides, he pointed out, well, this thing is like a little bit harder to do in Akka streams than it is in ZIO. And I think within 24 hours of that, we had like a pull request merge that like added something that made that easier. So I think that's one thing for like all of us is, I think I would think of everyone who's like, listen to this as part of the ZIO community of you're spending time listening to this. You're oftentimes either asking questions on the Discord or raising issues or pull requests. But this whole thing is an opportunity for all of us to just make ZIO better and kind of take anything that we're like, oh yeah, this is harder to do, and say, well, how do we make it easier and take what we're doing to the next level? Okay, I've got some stream examples. Maybe let me I'll give a high level overview of this. So these are basically some stream examples that I also copied from Akka's documentation. I don't think we'll have time in this session to go through all of them and through converting them, but I think this is actually an area where it's pretty straightforward a lot of the times, where so in Akka, you've got this distinction between what they call a source, what they call a flow, and what they call a sink. And so a source, like its name kind of implies, like produces elements. A flow consumes and produces elements. And a sink consumes elements. For folks who've maybe been in the last few Zymposia, what data types do these sound like? Go back to Discord. Yeah, exactly. So if this is the Akka world, and I'm not sure I'm as good at doing the art here, but so this is a Z stream. This is a Z pipeline. And this is a Z sync. So in one case, it's exactly the same, except for putting a Z in front of it. I mean, the others are like slightly different words for the same things, but this is actually a pretty close correspondence. And so you'll see a lot of the times it's pretty straightforward to translate at least code that's written this way. I think when you get to like the kind of more like DSL type part of Akka streams, there can be a little more of just like a difference. But if you look here, so maybe let me try to do, I'll call this ZIO example stream. So how do we do this in Akka versus ZIO? Well, the first thing we do is like, so in Akka, there's like this actor system and dispatcher and all this. We kind of blow that away, but we have our own little bit of stuff of we do ZIO app default, and we're going to do run with something. I don't need to worry about this terminating the actor system thing. And so if I want to translate this, so I say, okay, well, the source is basically like a Z stream. And if we know about Akka, we know that this first type is like the type of elements. And then the second type is this materialized value, which a lot of times will not be used. And so here I'm just going to translate this into a Z stream, any nothing int. And then maybe my first approximation is going to be to just do Z stream here. And well, first let me import ZIO. Okay. Let's see, what have I feel like I've blown up a bunch of things maybe with those imports. So let me copy this into another. So I won't need those imports anymore. Okay, and so we've got two errors here, and let's work through them. So the first one is a pretty minor thing that I guess in Akka, this thing accepted directly an iterable versus in ZStream, we just do ZStream.from iterable. So fine. And then the run for each is actually the same. That method exists in both of them. So we don't actually need to change that. The only difference is that we use the ZIO version of printing. And we're good to go. Boom. And so you'll generally find that that's the case here of like a lot of these operators you can do in exactly the same way. So like here, like, okay, we can scan over a source. Sure. Well, we can scan over a source too. We can do yeah, overflowed at some point. Well, because I should have used a big end there. And if I want to, just like with Akka, I can send, so like this is kind of their specialized sync. And I can do exactly the same thing with like a Z-sync. So there's a, get us to Z-sync, it's from path. I think there's a, or I can do a Z-sync, excuse me, from file or Z-sync from file name. And I can construct my own sync that this is going to go to. And just like an Akka that can write to a file or do what have you. So there's a really nice analogy between the high level streaming data types there. Okay, let me check in again on Discord. Anything else anyone would like to see? Okay, so we got a whole bunch of questions here. So let's take a look at this. How do we implement graceful shutdown in ZIO? Can it be expressed via layers and scopes? So they get between parent-child termination. Okay. Yeah, so that's a really great question. And so that's where this data type or this concept of scopes comes in. So let's try to like play with this a little bit. So let's say, I think if I'm understanding you correctly, that when this stream is closed, we need to be sure that something is done. I'll just go back to, but kind of
done, by the way, Adam, I'm back.
Sorry, about
dipping out.
Oh, fantastic. Cool. Okay, so yeah, so we're asking about this concept of kind of finalizers. So a really easy way I can do that is if I've got this and let's do something like ensuring. And right now I'll just do ZIO.debug shutting down. Well, great. So I've got this original source that maybe this came from a file or something. I need to close the file. I'm doing some transformations that right now are just like very mathy. Maybe I'll make this just smaller so I'll put super big numbers. And then I'm going to run this thing. And so let me run this. And so you see we got that shutting down source here. And maybe let me try to make this a little bit more interesting for us. So why don't I see if I can do oops. So let's try running this and let's see what happens. So this never does anything here. And because I put in this never here. So now let me try forking this off as a fiber. And then maybe I'll wait a second and then I'll interrupt it. And so you see, even though this got interrupted, we still shut down that source. So basically, anytime you want to do some type of like, I want to make sure this is done when I'm done, you can either use this ensuring operator, or the more complex version of it is there's an operator called ZIO dot require release. Or in terms of streams, there's a Z stream. There's a Z stream also with acquire release. And all of those are implemented in terms of this concept called a scope, which basically is a scope in which resources can be acquired, and then all of those resources will be released when the scope is closed. So I think it's a really, really nice question to get to. Yeah, that built-in support for safe resource management is one of the really nice features of ZIO. There was also a question here of does ZIO easily handle serialization, persistence, and clustering? So I think that's one of the areas where you can absolutely do that, but you need to put together a couple of different components in the ZIO ecosystem. There's a library called Shardcake that helps you do that. And I think if you can use that in combination with a couple other ZIO libraries to do that. But that is something where I think Akka's definitely built a lot there, and we have more building to do. So you can't
Give
do
us a couple of weeks. Just a couple of weeks.
Give us a couple of weeks. Exactly. Anything else from anyone?
I'm blonde now. Yay.
Whoa, that's amazing.
It looks weird. It looks weird. So yes, sorry for being out today. I was making a hair decision. Felt like being different. But yeah.
So let me maybe take some of the stuff out here. Oops. This one. Let's see tutorials. Just delete this so we can see this now. Yep. So now we're writing it to the sync. And again, it's very, very similar in a way to the Akka example. Slightly different operator names, maybe slightly different operators, but the core concept here of we have this source or stream that we are able to transform, and then eventually we're able to send to a sync is exactly the same. So I think this is one of the areas where it's pretty nice going from one to the other. One thing that I do think that ZIO does a little bit better here is it's more explicit about when you are essentially running the stream. So for example, if you, like they have this example here where basically they're like working with all these tweets and they have this like reduce operator. And this reduce operator is going to take your whole stream and reduce it to a single value, but it's still going to give you back one of these sources. And so this is like, at least I find in like organizations I work with, one of the most common like problems I see with streaming is it's what I call kind of fake streams of like, oh yeah, the signature looks like it's a stream, but actually you already pre-computed all the values to like get to this point. You're not incrementally producing the values. And one of the things I like about ZIO is it makes that like very explicit of if I've got something like this factorials and I want to do like factorials.fold, well, that doesn't exist. What exists is runfold. And what runfold returns is a ZIO. So it's super explicit that like, hey, if you're going to fold over this whole stream, this thing is not going to be done until this stream is done. Versus maybe if I want to do something more incremental, well, maybe I want to do something like a scan that is going to remit those results incrementally and let me consume them incrementally. I'm sure we're going to be getting more into streams because there's, I mean, just like in our whole ZIO stream session, there's a whole set of things of how do you broadcast and how do you fan in and how do you do all these things, and they've got a little bit of their own domain specific language there versus we kind of more just do it in code. But it's probably more than we have time for today.
I know at the beginning you were definitely couching some or qualifying some of these opinions that we may be biased, but I would just like to assure everyone, personally, I'm not biased, and I agree completely. I mean, to just reverse, I remember when I came to Scala like 3 years ago or so, and was confronted with Akka. No offense to Akka, though. I mean, I guess everyone's kind of kicking it these days due to their open source decisions. So maybe I don't feel so bad, but yeah, it's API. I had basically, I kicked that can down the road, and luckily I found ZIO before I sort of had to cave in and learn Akka. But all of these, the implicit actor systems, the implicit dispatchers, it just seemed like there was so much terminology that got entered right away, and you had to sort of implicitly set things up. It seemed very, very heavyweight and confusing, especially I looked at some of their like streaming composition symbolic operators for describing pipelines. There were like a million different incantations. I mean, everyone does symbolic operators. We're all guilty, but that looked particularly noisome. But the ZIO version being sort of just a functional description of what to do with the stream. You don't have to have some actor system in scope. I mean, you have to run it eventually from within the ZIO app, but it's so nice not to have to weave together all these materializers and dispatchers and all these terms, which I luckily am fully ignorant of, and will remain benighted gleefully. But it's for those who need to translate, hopefully things become simpler. Though I'm sure maybe there are this terminology we use that's confusing as well, like chunk. It's a chunk.
Yep. I think Naveed had one question about. Okay, well, we got a couple of questions. So we got one about should I make things uninterruptible? So ZIO does give you this ability to have very fine-grained control over interruptions. So you can say like this particular block of code I want to be uninterruptible, or this particular block I do want to be interruptible. I would generally advise like don't do that yourself. Like it's just too low level. Take advantage of these operators. So take advantage of ensuring and acquire release. And scopes, and there's a whole set of like higher level things that will just do the right thing for you and make sure that if you have a finalizer, it does get run and keep you out of any of gotchas. There's also a question of what's the best practice for working on stream, when to run or materialize a stream. Yeah, so I think generally if you're most time when I'm like working with streams, I think of like the stream as like the paradigm of my application. And I think streams are useful because that's a pretty like useful paradigm of you can say, whatever I'm doing, I'm making lending decisions, and I've got a whole bunch of data coming in that's like new information of people who like want loans and things they've done, and that's basically a stream or maybe multiple streams I'm going to merge together. I like have some logic I need to do to like update what I know. That's kind of my like pipeline in the ZIO parlance. And then out of that, I need to like potentially emit some things of I need to like, here are like the decisions, or here's like the information needs to get updated to the database. And so I would kind of then think about like my whole application as a stream, and kind of when I start my application, I'm starting a stream that is essentially maybe running forever. Obviously you can run, if you have like kind of simple streams like this, you can run them anytime you want to, but I find that's a pretty helpful like paradigm, or just whenever you're done with it, if maybe you're like reading a file you're reading streaming file input because it's like a big file, well, you stream it until you're done with the contents and do whatever you do with it as a stream. But yeah, I would generally recommend staying in that streaming world as long as you can. Okay, and Naveed's got some feedback from ZIO, which is great. I think that's really good feedback. Let's just make sure we, if you have any specific feedback, would love to get that and to get that into tickets. Hopefully we're already in the process of addressing some of that, but yeah, ZIO is a super important library. And I think the Dream11 folks did a fantastic job of like taking it from like not existing to already being great. And I think there's a lot more that we can do, but part of how we get there is we also acknowledge like everything that isn't working as well as it could be, and we keep fixing it.
Yeah, I know we've been having some fun this week with that, Adam. So I'm excited when our work is ready.
Yeah,
I'm sure we'll talk about it here in a few weeks' time.
And then Domdorn has a question about adding async boundaries. There's an operator called aggregate async, and there's another one called grouped within that's implemented in terms of that I would take a look at if you want that type of behavior. But okay. I think we always managed to go longer than our time, but this was really fantastic. Thank you so much, everyone. And again, please like share your own questions. We know there's a whole Akka ecosystem out there, and if you're like, hey, like we need more help with doing config, and like how do we not use like different config solutions, like we can do a session on that, or we definitely want to do one on Shardcake. But please like give us your questions, and we'll use those to focus the further sessions we do.